this is Dr. Hanaa Assil, and this is the second part of review questions on Modular Unit 2 in the IGCSE Chemistry Edexcel. So this question says ethanoic acid reacts with ethanol to form ester A and water. Remember, an acid plus an alcohol gives an ester plus water. Complete the equation by adding the displayed formula of the ester. How do we draw the ester? We said we have the acid and the alcohol. We remove the OH from the acid, the H from the alcohol, and join. So we draw the acid first without that OH, and then we complete it with the part from the alcohol. So that is the ester. Now, how do we name this ester? We said we start with the name of the alcohol. So this was from ethanol, so it is ethyl something. And the acid was ethanoic, so the ester is ethanoate. That's how we name an ester. Methanol is heated with potassium dichromate and one other reagent. The methanol is oxidized to methanoic acid. Remember, we change alcohols to acid by oxidation using what? Potassium dichromate. Now, what is the formula of the other reagent? It's potassium dichromate with sulfuric acid. We are required to write the formula, so please write the formula. Now, when we oxidize alcohol to acid using potassium dichromate, what is the color change that occurs? You should realize that potassium dichromate is originally orange, and when it reacts, it changes to green. Draw the displayed formula for methanol and methanoic acid. Of course, meth means one carbon. Methanol means it has an OH. Please remember, displayed formula has a bond between the O and the H. Methanoic is an acid, so it must have C double bond O, single bond OH, and one carbon, so just one H. Do not forget that any carbon must have a total of 4 bonds. Then the next question says, methanol reacts with methanoic acid to form an ester. Complete the equation. How do we write an ester? We said we start with the acid, and then we remove OH from the acid, H from the alcohol, and join them together. So this would be the formula of the ester, and of course the other product is water. The structural formula of an ester is given. What is the name of this ester? Now, if we draw it out, this is what it looks like. Remember that the part that has the C double bond O, that's the acid. The part on the right, that's the alcohol. Now, when we name, we start with the name of the alcohol. So the part on the right has 4 carbons, that is butyl something. Now, the part that has C double bond O, that's the part that was acid. So this is ethanoate. Now, what is the molecular formula of this ester? You add up all the carbons, hydrogens, and oxygens. So the molecular formula is C6H12O2. The scientist electrolyzes molten lead bromide using this apparatus. Explain why lead bromide needs to be molten rather than solid for electrolysis to occur. Again, lead bromide is ionic. It needs to be molten. Why? To have free moving ions. Now, when solid, remember that when solid, the ions are fixed in a 3-dimensional crystal lattice. So why does it have to be molten? The ions are free to move when molten, so they can conduct electricity. But when solid, ions of any ionic compound are fixed in a three-dimensional crystal lattice, so they cannot move. The electrolyte is at a temperature of 400 degrees Celsius. Remember, we need to heat the lead bromide until it's molten, so we need to heat it to a very high temperature. Explain a suitable material for the electrodes. We said the electrodes should be made of graphite, or you could say platinum, because it has high melting point. Remember, if he says explain, you have to explain. Give the half equation that occurs at the negative electrode. What are we doing? We're doing molten lead bromide. Think about what are the ions that we have. Which one will go to the negative electrode? Of course, it is the lead 2+ that goes to the negative, gains electrons, and becomes lead atoms. Bromine forms at the positive electrode, and we're given the half equation. State what is observed at the positive electrode. Obviously, it's giving bromine. So what are we going to see? Remember that at room temperature, bromine is a reddish brown liquid. But here we're heating to 400 degrees Celsius. So what we see is reddish brown fumes or reddish brown gas, because of the high temperature. State why the half equation there represents oxidation. Of course, this is because there is loss of electrons. The bromide ions lose electrons, and that is oxidation. State in terms of electrostatic attraction what is meant by a covalent bond. Again, what do we mean by a covalent bond? It is strong attraction forces between bonding pair of electrons or the shared pair of electrons and the positive nuclei of the atoms, the plural of nucleus, the positive nuclei of both atoms involved in the sharing. When hydrogen gas is dissolved in an organic solvent, the hydrogen chloride remains a covalent molecule. When hydrogen chloride gas is dissolved in water, ions are formed. Explain what happens when dry blue litmus paper is dipped into separate samples of each solution. Now remember that when we draw dot and cross diagram for hydrogen chloride, we draw it like this, because hydrogen chloride as a gas is a covalent molecule in which we have sharing of electrons. Now you should know that hydrogen chloride is unique. In organic solvents, it will not ionize, it will remain HCl, no H+ ions are formed, so the solution is not acidic when we dissolve it in organic solvents, and therefore if we put blue litmus, it remains blue. But if we dissolve the HCl in water, you should remember that in water HCl ionizes to form H+ ions. Now the solution becomes acidic, and if we put blue litmus, the blue litmus turns red. The box gives names of some substances. Complete by choosing a substance. Which of these is a good conductor of electricity? Remember, good conductor of electricity has to be a metal. So which of these is metal? Lithium. A substance that can be used to form a polymer. Remember, we can make a polymer from what? From an alkene. So which of these is alkene? That's it. A substance that has a giant covalent structures. Remember, which one did we say has giant covalent structures? Either diamond or graphite. Describe a test for chlorine. Again, I'm going to remind you, there is test for chloride and test for chlorine gas. Remember, the silver nitrate is for chloride, not chlorine gas. The test for chlorine gas is insert damp blue litmus paper. It bleaches. Remember, we said if we're going to use litmus to test a gas, it should be damp. So insert damp litmus paper, it bleaches. That means it becomes white. Calcium bromide is an ionic compound. The table shows formula and melting points of caffeine and calcium bromide. Relative formula mass of calcium bromide is similar to the relative formula mass of caffeine. So both of them have about the same MR. Explain why calcium bromide has a much higher melting point than caffeine. Again, of course, we're told and we should know that calcium bromide is ionic. Now, the fact that it is ionic, it should have very high melting point. Why? Because strong attraction forces between positive and negative ions in a giant crystal lattice. This needs a lot of energy to separate the ions or to melt the solid. But caffeine, we said, has lower melting point. That would mean that it has simple molecular structure with weak attraction forces between the molecules that need a small amount of energy to be broken. A student does a flame test to see if a white solid contains lithium. They clean a platinum wire before using it for the flame test. Explain why the student needs to clean the platinum wire. Remember, the first thing we do in a flame test is clean the platinum wire by dipping in concentrated HCl. This is to remove remains of any previous substances that would interfere with the color of the flame. Now, what is the color of the flame if the solid contains lithium ions? You have to know the colors of these flames. Lithium is, of course, red, sodium yellow, potassium lilac, calcium orange red, copper blue green. Again, I will remind you, this is test for the ions, not for the metal themselves. What is the approximate percentage by volume of nitrogen in the atmosphere? Again, you should remember nitrogen is about 78%, so the choices here would be 80. Remember that oxygen is about 21%, carbon dioxide is about 0.04 or 0.03, and argon is about 0.9%. Complete the dot and cross for a molecule of nitrogen. Remember, each nitrogen is in group 5, has 5 electrons in its outer shell. So each nitrogen needs 3 more, and that means they're going to share 3 pairs of electrons, but each of them still has the rest of the 5 that it started with. Nitrogen dioxide produced in car engines react with water vapor and oxygen in the atmosphere to form nitric oxide. First of all, write the chemical equation. So nitrogen dioxide, of course, that's NO2 plus, we are told, plus water plus oxygen to give nitric acid. Please remember how to write an acid. Then we have to balance. Please do not leave the equation without balancing, and do not say they did not ask for balance. It is understood that a chemical equation has to be balanced. So if we balance, you will find that you will need to put 4 in front of the NO2, 4 in front of the nitric, and 2 in front of the water. That way all of them are balanced. Nitric acid forms acid rain. State 1 environmental effect of acid rain. Again, acid rain kills plants, marine animals, dissolves the limestone in buildings, affects the lungs, the respiratory system. So you could say any of these, that it destroys plants or kills plants, it kills marine animals, it dissolves the limestone in buildings, causing them to crumble, or it damages the respiratory system. A technician finds an unlabeled bottle on a shelf that could be ammonium carbonate. Describe tests that the technician should use to confirm that the solution contains ammonium ions and carbonate ions. So how do we test for ammonium? Remember, add aqueous sodium hydroxide and warm gently. Bubbles of gas are formed that turn damp red litmus paper to blue. This is because a base with ammonium salt gives ammonia gas. How do we test for carbonate? Carbonate, we add dilute HCl. We get bubbles of gas are formed that turn lime water milky. Please remember how to explain the tests, all the tests that you're required to know. The alkene C3H6 can be polymerized to form polypropene. Draw the repeat unit of polypropene. This is propene. And we said, how do we draw the polymer? We look at the two carbons that have the double bond. Write them with a single bond, the bond on the right, bond on the left, bracket N, to indicate that this is repeated N times. And then you look at each carbon. The carbon on the left of the double bond has a hydrogen and a hydrogen. The carbon on the right of the double bond has a hydrogen and a CH3. So this is the repeat unit for polypropene. These are two methods for disposing of polymers. Method 1, burying them in landfill sites. Method 2, burning them to release heat energy. State one environmental problem linked to each of these methods of disposal. What is the problem of throwing polymers in landfill sites or in dump sites? We said they are non-biodegradable since they're inert, so they accumulate in the dump sites. When we throw them, they accumulate in dump sites. And if burnt, what happens? They release toxic gases. A student uses this apparatus to investigate the rate of reaction between marble chips and dilute hydrochloric acid. Again, state why mass is lost from the flask. We said the mass will go down because a gas is given off and it escapes. So which gas are we talking about here? Carbon dioxide gas is formed and it escapes. What is the purpose of the cotton wool? Why do we need a cotton wool at the mouth of the flask? Remember, we cannot close it completely with a bung because we want the carbon dioxide gas to escape, but we should not leave it open because remember that any solution that is giving out a gas would bubble over, so we want to prevent loss of solution by splashing. This is a graph of the student's results. Explain the shape of the graph. You should assume that the marble chips are excess. So he was reacting what? Marble chips with dilute hydrochloric acid. That means it is dilute hydrochloric acid that is limiting. What is happening? Now, at the beginning, and he's saying explain the shape of the graph. So at the beginning, the graph is steepest. Why? Because this is the fastest rate. Why? More particles, so more collisions per second. This is when we started, we have a lot of particles. Then the slope becomes less steep, rate slows down because the particles are used up, so less collisions per second. And at the end, the curve levels off, the reaction has stopped. Now, why has the reaction stopped? Because one of the reactants has been used up, and you have to specify which of these is being used up and has been used up. It is the acid, because we're told that the marble chips are excess. On the grid, draw the curve you would expect to obtain if the student uses the same volume of hydrochloric acid but half the concentration. Remember, we said if we're talking about the limiting reagent affects the final volume of gas obtained. So if I am using half the concentration, then I will have half the final volume of gas. So amount of gas that is formed will be half if I am using half the concentration of the limiting. If we were talking about excess, it wouldn't make a difference. It will just make the reaction faster or slower. But when we're talking about the limiting reagent, that affects how much product I get. The student repeats the experiment using the same mass of smaller marble chips. So explain using particle collision theory how using smaller marble chips would affect the rate. Remember, smaller pieces or powdered means larger surface area, and that means faster reaction. So if we were to draw the graph, the graph for these smaller marble chips would be a steeper curve but the same final volume. Now why is that? Because smaller chips have larger surface area, so more collisions per minute or more frequent collisions, so the reaction is faster. A student uses this apparatus to investigate the rate of reaction between dilute sulfuric acid and excess of small pieces of zinc. So remember, the zinc is excess. Now we're using 50 centimeter cubed of dilute sulfuric acid. Add about 5 grams of small zinc pieces to the sulfuric acid. Quickly connect the gas syringe. Record the reading on the gas syringe every 30 seconds until the reaction stops. And the first question is, name a suitable piece of apparatus to measure the volume of sulfuric acid. What do we want to measure? We want to measure 50 centimeter cubed of dilute sulfuric acid. Remember, it did not say, for example, 50.0. So we don't need it to be very exact, and therefore a measuring cylinder would be enough. If we're trying to measure something 0.0, then we should say either a burette or a pipette if it is 25.0. Give a reason why the mass of zinc pieces does not need to be measured accurately. He's saying about 5 grams of zinc pieces, because up there he already said that the zinc is excess, so it doesn't matter if it is a little bit more or a little bit less. Give a reason why the student quickly connects the gas syringe in step 3. Of course, zinc with sulfuric acid will give out hydrogen gas, so we need to connect the gas syringe quickly to avoid escape of the gas. State how the student would know when the reaction stops. Again, when the reaction is going on, bubbles of hydrogen gas are being given off, but when the reaction stops, then no more bubbles of gas or no more gas collects in the gas syringe. The graph shows the volume of gas collected in the gas syringe. A tangent to the curve has been drawn at time 80. Use the tangent to calculate the rate of the reaction. Again, please remember, if you have this kind of graph, volume versus time, remember to get the rate at any specific time, we draw a tangent. Here, he already drew the tangent for us. In order to get the rate, we get the slope of the tangent. Slope means the difference in the y-axis divided by the difference in the x-axis. So according to this graph, the rate is about 0.33 centimeter cubed per second. Explain the shape of the graph in these regions. Again, at the beginning, from 0 to 60 seconds, what is happening? The graph is steepest. This is because this is the fastest rate. Any reaction is fastest at the beginning because more particles, so more collisions per second. Now, from 60 to 150, the curve is less steep. The rate is slowing down. This is because particles are used up, so less collisions per second. At the end, the curve levels off. Reaction has stopped. Now, one of the reactants has been used up. Remember, it is the sulfuric acid that has been used up, not the one that is excess. Complete the dot and cross diagram to show the outer shell electrons in a molecule of hydrogen chloride. Again, hydrogen has 1 electron. It needs 1 more from the chlorine. Chlorine is in group 7. It has 7 electrons. It needs 1 from the hydrogen, so they will both share a pair of electrons. And remember the rest of the 7 electrons that are for the chlorine. The diagram shows the electronic configuration of a magnesium atom and a chlorine atom. Draw the electronic configuration of magnesium ion and chloride ion. Remember, magnesium is in group 2. It has 2 electrons in its outer shell. When it reacts, it loses these 2 electrons in the outer shell. So now it has only the rest of the 12, so 2 and 8. It has lost 2 electrons. That means it now has 2 positives. The chloride ion has 7 in its outer shell, or the chlorine atom has 7 in its outer shell. It needs 1 more, so it takes 1 from the magnesium, and that means for each magnesium I need 2 chlorides, but each chloride takes only 1. You cannot put 2 for the chloride. Each chloride ion has 1 of the electrons from the magnesium, and that means it has 1 negative charge. Explain why magnesium chloride has a much higher melting point than hydrogen chloride. Again, magnesium chloride is ionic. That means it has giant 3-dimensional crystal lattice with strong attraction forces between positive and negative ions that need a lot of energy to be broken. Anything else that has low melting point, such as HCl, this is because simple molecular structure with weak attraction forces between molecules that need a small amount of energy to be broken. This is the equation for decomposition of hydrogen peroxide. The rate increases when a catalyst of manganese oxide is added. Describe how a catalyst increases the rate. Again, how does a catalyst increase the rate? We said a catalyst provides an alternative pathway for the reaction with lower activation energy. So the reaction in presence of a catalyst has lower activation energy. Again, in the energy profile diagram like this, the activation energy is the difference in energy from reactants to the top. A student adds 50 centimeter cubed of hydrogen peroxide to a glass container and then adds 1 gram of manganese oxide. Name this glass container. What is the name of this container? This is a conical flask. The student waits until the hydrogen peroxide completely decomposes. Describe how the students could then show that manganese oxide was a catalyst and not a reactant. Remember, how do we prove that something is a catalyst? We are told that at the beginning he added 1 gram of manganese oxide. And we said a catalyst speeds up the reaction without being changed. And that means if I filter the mixture through filter paper and funnel, dry the residue and weigh it, it should still be the same mass of manganese oxide that we started with, and that shows that it is not a reactant, it's just present there to make the reaction fast. Diamond and graphite are both forms of the element carbon. Diamond and graphite both have covalent bonds and giant covalent structures. Describe the forces of attraction in a covalent bond. Again, for any covalent bond, strong attraction forces between bonding pair of electrons and positive nuclei of both atoms, not positive nucleus. Okay, explain why graphite conducts electricity. Remember, graphite is the only non-metal that conducts electricity because it has free-moving what? Free-moving delocalized electrons. Explain why diamond is hard but graphite is soft. We said diamond is hard because it has strong covalent bonds between carbon atoms in the rigid three-dimensional tetrahedral structure, while graphite is soft because weak attraction forces between the layers allows them to slide past each other. And that's the end of these questions on Modular Unit 2. Good luck in your exams.